you hear me?
Yes.
Yes.
Thank you.
Hi, Professor. I have a question. Do we need to like capitalize the answers in quiz 3 or all
Yeah, it's
lowercase?
yeah, all text is case insensitive.
Oh, okay.
Can I get the access code, please?
No, there's no password. And it's quiz 3, not 4.
Oh. So, Professor, do we need to start the quiz 3 right now?
3, yes, quiz 3.
All right, thank you.
It's quiz 3, not 4. It's case insensitive.
Oh, so yes.
No, it doesn't matter.
Okay.
The table names. Just
Yeah, those are the table names.
then in here, what is cellular? Like, where's the cellular?
If you read that, then it's self-explanatory. If you understand that select, then it's self-explanatory. But I'll think if you put CVM right there, yeah, it's a table OS.
Okay, so that's why I'm confused.
Yeah, it's a
'cause, like,
renaming of the table.
Is the comma not allowed here as well? Just in general?
Sorry,
Like, is it's just like the comma's not allowed?
comma. Yeah, don't use any.
Not even here?
No, yeah, don't.
Okay.
Yeah, don't use punctuation, commas or periods or colons or parentheses or quotes.
There's some problem with this question because, like, I don't know where's IGHD.
So that's a renaming of the table.
Oh. And I have to aggregate on this. I need to count ZU.SCID. What if I do that? I'm not using SC anywhere because it's written form. So that is why I'm getting confused. Because I'm selecting ZU.SCID, which is an NR, which goes in here.
Mhm.
And then I'm doing count off. But I wanted to do this as ZU.SCID. But if I do it as ZU, then I'm not using SC anywhere.
Well, you are, right? It's right there.
I didn't get you.
The foreign key and the primary key.
Yeah, it's joining on this, right?
Yeah.
But then the count will come from this table because this has
The,
multiple
the
rows.
count of what?
The count of SCID.
Oh, okay.
Because that is what we're printing here.
Yep.
328 2 times 676 1 and 825 is 3.
Yes.
So I want to take ZU.SCID count.
You want to count?
ZU.SCID. But if I do
Oh.
that, I'll be using just one table. because ZU is already
I
being
know,
used.
but you're already using two tables here, so you have ZU right there.
If I write ZU right there, but then I'm not choosing any column from ZU. That's fine.
But you're grouping by it, so you can put it there. Yeah, you're grouping now.
Yeah, I'm grouping by ZU.scit.
Yeah, so that's correct.
Then if I want to make this a ZZ, this will be right according to me.
Yeah, it is.
But then I'm not using any column from SC. Is that fine?
But you are because we're using that column to do the join.
Join. Okay,
Yeah.
got it, got it, got it.
This query is very probably I'm not using this. You're using for joining. Yes. Okay. Yeah. Is there a question here?
Are the tables in question 1 and 2 related, or are they independent tables of one another?
Which one?
So there's a B here, and there's a B in the question 2 also.
Oh no, not related.
Okay, cool.
All right, who's done? Who's not done?
I think that's use comma instead of and like in the
Mhm.
table. So I think that's why I felt like that points off. But
If there's yeah, no commas.
okay,
But if it's correct, I'll give it to you.
okay, it's like
Just let me know.
B and C.
Mhm.
from
Yeah.
But it means
Yeah, actually, I'll make all the quiz available. Mhm.
For answer 4,
Mhm.
my answer was bool. These were the accepted answers. I clearly meant boolean. And in my SQL, I think that when I typed in bool, it accepted it.
Yeah, I'll give you that. Which one is this?
Quiz 2.
Okay, that's recording. Can you see my screen?
Yes.
Awesome. And let me just. Okay. Yeah. Let's see. Yeah. So I'm gonna just review real quick on the material. You might have seen the video from last week. It was all about updating the database using the instructions of inserts, updates, and deletes, right? And there were several versions of the insert statement, right? The simplest one that you just give us the name of the table and then the values, comma separated. And this assumed that the values were given in the same order as the fields that when they were declared, right? So in this case, we give the names of the field, the primary key, first, last, and so on and so forth, in the order that the fields were declared, and we just are able to create a brand new record, right? So it is, we do assume that that you are giving the data in the order in which the fields were declared, and the same data type, and also you could leave out values. And if you did, then the default value was used. Also, if you had declared it as not null, meaning that it was required, right, you could not skip over that field, right? You would get an error. If it was explicitly declared as null, then it was not required. You could just leave it as null, but not null where you could not skip over it. And you could certainly provide a default value. For instance, here you could skip over D as long as you give it a default value. If you don't give it, it'll take a 123.45, or you can override it, but actually providing a value. You can't just skip over just by putting extra commas. If you want to skip over C, you would have to instead explicitly provide a null, right? And if C allows you to put a null, right? If C says not null, then you would get an error, right? So yeah, we are allowing the null, right, by providing the keyword null, whereas we're making some fields required, saying not null. So B and D are required because we have the not null in there. There's alternative syntax where instead of only the values, you could also provide the name of the columns, so that if you can now not have to rely on any particular order, right? So you can mix and match and move the values and the columns around, right? So here we are saying that we are only providing the primary key, last, and first, but they don't have to be specified in that order, right? You can move the columns around, right? And then the values would have to follow the order of the columns that you're specifying. So here, right, we have to make sure that they align, right? That if you're providing the name and the major ID and graduate year, then the values have to match the columns that you are providing. Same rules apply on values that you're skipping over, that you're not providing value, right? It's okay if you had declared them null, right? But if you had declared them not null, then obviously you have to provide it. Otherwise, you get an exception. Unless you provide perhaps a default value, it'll take that instead. So here's just a couple of examples of what would happen if you insert some values that are required or that you are declaring them as default. D, if you're not providing a value of D, which you've declared not null, right, you'll get an error, unless you perhaps give a default value, right, and then you'd be okay. You can also copy, right? So data that might be elsewhere and perhaps spread out over multiple tables, right? You could do a select statement that retrieves data from multiple tables, joins them, right, based on some criteria, and identifies all the records from these other tables, puts them all together in a single result set, and then you can copy and insert it into another table, right? So obviously you would have to create first a table with that particular schema that you're expecting, right? And it would also have to make sure that the data types of the source tables, right, match the data types of the target table, right? And also you have to make sure that you have to rename the fields, right, as the target table, right? Otherwise you won't know which values match with what column, right? So here's just an example where we first create an alumni table, right, that has the primary keys, the names of the students, what they graduated and when they graduated, and then we can insert into the alumni table by retrieving data from the students table and the department, see when they graduated. If they graduated after a certain year, then they're alumni. Otherwise, they don't make it to the alumni table. Now, notice that this obviously would be a kind of like a redundancy, right? If you can select data from the database, right, and you're literally copying that into another table, that is creating redundancy, right? It's data that you already have, right, and that you are making it redundant in another table, right? So obviously you would be doing this. Probably a better solution would be to instead have a view, right, where you still have the data available, but you're not creating the redundancy, right? Perhaps this was a design decision to create a what is referred to as a materialized view. A materialized view, we've seen views, right? And view is just basically a select statement that you put a name on it, right? Create view, and you can give it a select statement name so that you can treat it as if it were a table. That has the benefit of not introducing redundancy, right? Because it's not a real table, right? And it's always rerun every single time, but allowing DB users to have a particular view into the database, right? That might be more convenient for them, right? So an alumni would be a perfect example of using a view instead, right? Now, some of these views might be very expensive to generate, right? And they and recalculating every single time might be very, very expensive, right? So if you have a view that has lots of read operations, right, that have a lot of traffic, you might consider, to improve performance, to actually make a view a permanent table, right? Like for instance, like this alumni, there is redundancy, and you are deliberately doing it knowing that you're introducing redundancy into the database, and we all know the risk of redundancy. You are introducing the risk of inconsistency, right? That you might be, what happens if you change the original tables, like the departments and the students and whatnot, right? Somebody who had not graduated now has graduated. Now the alumni table is stale, right? Because that person has not made it into the alumni table, right? Even though if you ask all the student table and everybody else, yes, this person has graduated. Yes, they should be an alumni, but they're not in the alumni table because they have not. You have not updated your alumni table, right? So that's the problem of inconsistency. So materialized views would use the techniques that we're going to see in a minute, triggers and store procedures, right, to make sure that this view would be always up to date, right? That it would be a managed redundancy. It would be a redundancy that you know about, right? But you have taken care of to make sure that you mitigate that risk of inconsistency, right? Yes. Yeah. Correct. No, if you don't provide, well, integers are by default 0. It'll take that, and characters will be empty string. But in like tiny int or things like that will not, or dates, things like that will not take the default value. You have to specify default, right, and the value that it is. Yeah. Yeah, well, you can configure them to take that,
by default, out of when the database you just purchased no, there are no defaults. Usually we tweak them to take that so that it behaves like programming languages, right? That we would assume that all integers would be initially initialized as 0, right? But by default, out of the box, there's no default. Everything is by default is null. Yeah. Yeah, no. So right. So it depends on the use case, right? That some things are just optional, right? If you have a long form from some folks to fill out, there'll be some things that you can absolutely not have optional, right? You require me to tell you how many children you have, or what is your address, or what's your email, right? And I can't let you go continue unless you tell me those things, right? And there might be a whole bunch of questions that are optional, right? You don't have to tell me this, you don't have to tell me that, and those definitely could be nulls. I allow you to give me a null, meaning it's unknown. I really don't know, and it would be erroneous for you to provide a default for those, right? Others you would definitely provide a default, maybe a salary or something to make sure that it's not negative. That if you don't tell me, at least I'll take 0 as a default, right? So it depends. It's case by case. There are certain things that are unknown, and it's okay for them to be unknown until you deliberately tell me, right? Yeah. 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 For instance, you register, right, and you're required probably to provide a password and email. So obviously those would be not null, but you're not required to tell me your first name and last name, right? And not until you tell me first and last name. For me, it would be erroneous to put a blank, right, a blank string in there, because the string can be compared, and I lose the knowledge that I don't know your first name and last name, right? If I actually put a string, I would have to put extra checks to check if it's empty string is that I don't know, as opposed to just null is already a flag telling me that I don't know your first name and last name, right? So null is already enough information for certain logic, right? To know that I don't have this information, and it's okay for me to not have it until you tell me specifically, right? So not knowing is a is knowing something. No, if you literally don't know and it's okay not to know, then I would leave it null. Absolutely. Yes.
When I created I was surprised to see, I thought like we were going to compute it kind of on the fly, or we compute it on the fly. But when I like
what was computer on the fly?
Or views, or
oh, views, yes.
Then I created views in Workbench, and I mean they populate in the under the views tab or folder.
Yeah.
And then if I try to run the create another time, it'll error out. So maybe it is computed every time, but
yeah,
I can't create it multiple times. It seems like it, at least on the surface, looks like it's being stored. Maybe it's not.
No, I mean it'll cache. It'll create a cache on the Workbench side, right? So if it detects that nothing has changed so far, right, it will not even make a network connection to the database, right? If it knows that you have not updated anything, right, it'll do some caching mechanism, right? Just to improve performance, right? But it's not. You can improve even you can improve performance by making the view permanent, right? Where it's now a literal table that you don't have to re-execute the query. And those are called materialized views, which is basically just a table. It's a table that it's redundant, right? Because it's based on querying some other parts of the database, right? And then you're making it permanent, right? And now you have to take care and mitigate all the risks of inconsistency, right? And yeah, and you do that using triggers and stored procedures, which we'll see in a minute. Yep. Yeah, see, redundancy. Yeah, so when you're inserting into these tables, right, you just have to be careful, right, that the target that you rename your fields correctly into the target table. There's also creating a brand new table out of the insert, right? So as opposed to making these two different steps where you first create the table, right, and then you insert using the select, insert select into the table, you can squish that into a single step, right? By combine the whole thing. So you create the table, and you don't have to even give me the schema, right? It'll figure out what the schema is from the source columns, right? That's coming from the source tables, right? So if you're retrieving these fields here, and this one's an integer and a varchar and a date and so on and so forth, right? The creates table will create the fields A, B, C, and D, right, with the correct data types from the source table, right? Which is pretty cool. So even if it's spread out over multiple tables, right, it'll figure out what the data. So without having to do the extra step of creating the table brand new. Or here we're copying and inserting a single record, right, from an insert into from a select statement into an insert. Here's just an example of creating the table from a select. Right, so yeah, different syntax. Not all databases support all these syntaxes. This is mostly for MySQL that support this syntax. Not all vendors support this syntax. So make sure to check. Let's see, anything on the chat? Please record. Yes, I am recording. We do have the update and delete, like the name suggests, right? Where you can remove records that are in there already, or update records that are already stored. So there's the syntax typically, delete from a table. The star is optional. Now, typically, you don't want to just do that without putting a where clause. Otherwise, you would literally be telling the database to just blow away all the records in there. Usually, you combine it with a where clause, identifying which records is it that you want to delete. Over here, we are telling to delete someone who has Edward Norton. Or you can be more specific, right? Have a select. You can have an inline view that retrieves a subset, like an array of values, right? That can then be used in an outer where clause, right? Where the second ID is not in this array of enrollments, right? So for instance, we might identify sections that have no enrollment, right? So just close those sections because nobody enrolled in them, right? Then there's also updates, right? That you can say which table you're updating, and you want to modify specific columns with specific values. Again, a where clause. Otherwise, if you don't put the where clause, it'll just change all the records, right, with that column and setting that value. So be careful. It just happened to me many times. So yeah, here we are setting the value for Edward Norton. Now we know where he lives, and we can he moved to Lowell, and we can change his address. Yes. I'm sorry. Yeah. Yeah, no, so right, so that's what they do is so updating data is very expensive because if you update a record, right, that means that needs to be an indexing needs to rerun, right? a brand new index needs to run if you are updating data, right? So if you have a table that has a lot of traffic where you're doing a lot of updates, that means that there's going to be a lot of re-indexing of the table, right? And that's very expensive. So oftentimes, if you have a lot of updates, they won't do the updates, right? They'll only insert, and they'll leave all the data in there. And so every time you do a query, you have to make sure that you're always working with whatever latest version of the data is, which will be the last insert that has been made into the record. So you have like an endless audit of how the changes of the state has been forever, right? Ever since that record was inserted at first. Right? So for instance, if somebody changes their address or changes whatever, right? You don't go into that record and change the address. You just do a brand new insert, right? Because updating would cause a brand new re-indexing, right, of that record, as opposed to every time you insert, right, you are only indexing that one record, right, and that's much faster than re-indexing the entire table. It's either by timestamp, and you just work with a last one that was inserted, and that's the only valid record in that table. Even though you might have 10,000 records, the only valid record is that one, right? Based on also it'll be joined with other things, right? That would perhaps have multiple records that are the latest ones, right? So there might be a whole bunch of students that you've updated, right? But there'll be the last 100 records of the latest students that you've updated, right? And yeah, it would be by timestamp or joined with whatever it is that you're updating. Yeah. We'll talk about re-indexing towards the end, and the how expensive they can be. Yeah, so this was an example of me forgetting the where clause, and it just made just moved everybody to Lowell. Now everybody's living in Lowell. But more typically, you do the updates on a particular foreign key or primary key, identifying who that person is. It is an example of a student that moved from one major to another major, from mathematics to maybe computer science, and now they're just going to take one more year to graduate, right? And then so we are updating their foreign key. We did talk about group by in the video, where we were discussing that oftentimes we want to be able to aggregate values, right? Where not only do we have records that are related to each other across tables, right? Where this record might be has a foreign key to this primary key in some other records in another table. So not only do you have records that are associated across each other across tables, but you might have records that are associated to each other within the same table. That they're somehow related because they might be part of the same regional area, right? Because they're all in the same state, or in the same zip code, or in the same whatever, right? However, you might want to identify them as them being in the same group, right? So a group allows you to do that, right? Allows you to identify a specific column and say that if the values in that column are the same amongst each other, then all the records are somehow related in that group, right? They all fall in the same bucket, right? So group by allows you to identify buckets, right, by a specific field, right? So for instance, here we could define 3 buckets by section ID, right? So now all the records that have the same section value fall in the same bucket, right? So here we have 3 buckets. There are 4 records in bucket 1, 4 records in bucket 2, and 4 records in bucket 3. Yes. And now you can say, well, I can aggregate, I can calculate something about each one of those buckets, right? I can count, for instance, those that, how many A's there were in that bucket, right? And so it says, well, in bucket 1, there are 2 A's. In bucket 2, there's 3 A's. In bucket 3, there's 1 A, right? I can do all sorts of things. I can just count, I can do average, I can do max, min, and there's a whole bunch of aggregation functions, right, that allow me to basically aggregate these values, right? Now you have to be careful that in those buckets, the only values that we can ask about are the values that were used to group them in the first place, right? Like, in that bucket, right? Everybody has section ID 1, right? And in this one, everybody has section ID 2, and so on and so forth. So we can ask about the things that we group by, yes? We can also ask about things that we aggregate, right? So for instance, if you aggregate about maybe the count of A's, then you can ask me, how many A's are there, right? And you can, about the count, about the aggregation of fields. Now, some things can be aggregated and some things make no sense to aggregate, right? So for instance, how would you aggregate the IDs? Well, those are unique values, no? Each student has a unique identifier, right? Would you be able to aggregate them in any way? Would it make sense to add them up? It makes no sense to add them up, right? And, that just has no logical sense of adding my student ID plus your student ID. Does that have any logic? No, it hasn't, right? Or asking about max and minimum about student IDs, probably that makes no sense either, right? So some fields make no sense to aggregate them, yes? But say you would, right? What falls in the buckets are only things what you can query about each bucket are either things that were used to group them in the first place, and only the things that you can aggregate. Anything outside of that, right? Remember, aggregations and groupings, right? But anything other than that, you cannot ask anything about in the bucket. So in those buckets, for instance, you cannot ask, oh, well, what was the ID? What are the IDs of the students in that bucket? Well, no, sorry. Only the things that you can ask are what you've aggregated, right? And what you have grouped. But anything outside is lost in the buckets. Make sense? Right? And that's gonna introduce a problem, right? Of the kinds of limitations that you have with these types of operations, right? And we just have to be aware of them, right? What are the limitations? So yeah, so the general syntax is that you were adding this group by at the end, and here are the columns that we can aggregate by. Like for instance, we were aggregating by section ID, but you can aggregate by multiple columns. But normally you aggregate by a single group, by a single field. So that field can be in the select statement. That's okay, right? If it's in the group by, it can be in the select statement. Other things that can be in the select statement are any aggregations, any aggregate functions. See, aggregate functions of some column, like, and the aggregate functions are min, max, sum, average, count, things like that, right? Things that collapse multiple values into a single value, right? The maximum value, the minimum value, right? The total count, the average, right? Those collapse a whole bunch of values into a single value. But you cannot have any other columns. You have to be careful, right? In the quiz, oh, maybe the quiz you just took, maybe, I don't know, I forget. Which one did we take? 3, which was selecting, right? Was there a group by question in there? Yeah, there might have been a trick question in there, right? Where there might have been a field that was not a group by, right? And obviously that would be the wrong answer, right? Because you cannot have a value that you do not, or was not in the group by or in the aggregation. So you got to be careful there. So these were just a couple of examples that we were grouping by customer. So there's 3 buckets: the Alice bucket, the Charlie bucket, and the Bob bucket, right? And in those buckets, there are dates, right? There are order IDs, there are order prices. Now, order prices might make sense to do some mathematical arithmetic operations, right? You can maybe ask the average, right? The average order price in the Alice bucket, right? That would mean that you would be adding all the order prices divided by number 3, right? And that's the average, right? For Charlie, you would be adding 1600 plus 100 divided by 2, and that's the average, yes? But what about order dates? Could you average or add up order dates? Or, well, I guess you could do min max. Min max would be okay, right? You could say, well, what was the earliest order, right? Or the oldest order, right? You couldn't do average, could you? Well, I guess you could maybe by time, maybe by difference, some difference, right? Perhaps. But but the actual values are gone, right? You don't have access to the original dates, right? Because they're being collapsed into a single value, right? So you need to tell me, how do you want to collapse it? Min, max, average, sum, concatenation, count. You need to, it's collapsed. So the original values are gone. So yeah, right. So for instance, you know, the order, you don't have access to the original order values, right, of each one of the values, because there's no way of accessing them, because all those three need to be collapsed into a single value by some aggregation function. Here we use sum, could have been average, could have been min, could have been max. All of them would make sense, right? Right. If you do not provide a group by, right, if you don't have a group by and you have an aggregation function, then the query assumes or interprets that, you know, as if all the records are one big group. Okay, right. So when you do the select customer, and if you have a where clause, then, you know, out of 40,000 records of customers, maybe you identify 1,000 customers, right, with a where clause. But if you don't put the group by, it'll consider that 1,000 customers as one single group, right? And whatever sum, it'll sum all of them together, right, for all the values. Yeah, multiple columns is that you can group by not only one column but two columns, and that means that, you know, if values in those two columns are the same, then they fall in the same bucket, right? Like customer and order date, right? So you're grouping by two fields. You know, here's just a couple examples on grouping by major ID and identifying the minimum and maximum graduation year. Some limitations, right? And the reason the limitations exist is that the way group by is calculated is that, well, first you need to identify what the records are that you're going to group by, right? So first the where clause runs, right? And, you know, runs all the ands and the equals or greater than, right, in the where clause, so that it filters 40,000 records, filters them down to 1,000 records. Yes. Once it has identified the 1,000 records, then it goes and creates the buckets, right? But first it identifies the records. Yes. Okay. So because it happens in that order, right, that first the where clause runs and then the grouping happens, you can't have grouping or any aggregation in the where clause. The where clause cannot have any groups, right? It cannot have any aggregations, right, as part of the where clause, because we haven't yet identified the fields, the records, right? If you haven't identified the records, there's nothing to aggregate. Make sense? Right. So first we have to identify the field. So it happens after the where, and it happens before the select. Okay, before the select. So first we identify the records. Out of 40,000, we filter down to 1,000. Then we create, you know, 10 buckets of 100 records each, right? Once we aggregate, now we can run the select statements, right, for doing the aggregations and the fields and whatnot, right? And that creates some limitations, right? So the example that we have here is that, you know, going back to the original example way back a couple of weeks ago, of that trying to count how many A's, you know, which sections had the most A's, right? And there were some limitations there, right? And the way we solved it was that we first we took a look at the enrollments. We created 3 buckets, right, of a group by section ID, right? It's this first query here. You know, we identify first the enrollments that have a grade of A. We group by section ID, and that creates 3 buckets, right? Which are these. Identifies these 3 buckets, right? And this gets aggregated into a single group, and we count how many A's there are. So 1, 3, and 2. So it creates 3 different buckets with counts. So that's this first query, the first query. Then the second query, notice that it's doing an aggregation, but it has no group by, right? That means that it takes all the records in here as if it were one big group, right? And it collapses it into a single value, right? Which is the max number of A's which is what we have here, 3. But, right, so what I'm trying to point out is that every time you go from a previous result, right, to the next one, you lose fields. I notice that in this one over here, you lost, right, the enrollment IDs, you lost the student ID, right? You lost those. You don't have those anymore over here. And once you go from here to here, right, you do the max, you lose the section ID, right? So here you don't have the section ID. So in this last query, it would be erroneous to ask, well, give me the max. Oh, and by the way, also give me the section. See that? Because I don't have the section here. It's no longer in the bucket, right? Because there were 3 sections in that in the bucket, and they were all collapsed into a single value, right? So those original 3 IDs, section IDs, are gone. I don't have them. Okay, so it would be erroneous to ask. It's unfortunate because, right, it'd be nice to say, oh, the maximum is 3. Oh, and by the way, it's section 2, right? So the way we got around that was to join these 2, right? We joined this last value, we joined it with a previous one, with the 3, you know, 3 is equal to 3, and then we got section 2, right? So that's why you have intermediate results, so that you can join them together and give you the value that you wanted, right? But it's unfortunate, right? Would it be nice that we could have done something like this? You know, you say, you know, select max Q number of A's as max A, comma Q section ID. That would be cool, right? Not only does it tell us the max 3, but it also tells us section 2. The problem is that we don't have section ID anymore. It's gone, right? You know, because, you know, first the where clause ran, then the buckets ran, and once that happens, right, you lose the section ID, so you can't put that in there. So that's illegal, right? It would not run, right? SQL would barf at this and say, no, sorry, you don't have section ID. Or we could have done. Would it be nice if we could have done instead this over here, where you give me, okay, give me the section ID, right? And we do the aggregation in the where clause, right? In the where clause, would have been nice to say, okay, well, where the number of A's is equal to the max Q of number of A's, right? But again, we can't. You know, this is you know, it wouldn't be nice to have aggregation on the where clause, but we can't do the aggregations because we haven't identified the records yet, right? So it's kind of like a you know, catch-22, right? So neither one of these is legal, right? There's you know, there's no syntax to support this, unless you use having. Having does support having aggregation on the where clause, right? Where you do the grouping, and then you have the having, right? Where you create the buckets, you can do the aggregation as if it were part of the where clause, and kind of fixes this limitation. All right, so here's just a couple of examples of doing aggregation on the where clause, and you know, adding up the orders that are less than 2,000, right? Which you could use this type of query to identify now the average, you know, the max number of A's, right, for the section. Okay. Anyway, right. So that was the material for last week. I see that most of you are all set with assignment number 5. You were asked to practice with updates and deletes and inserts, right, and copying, you know, doing select statements from multiple tables and copying into a target table. So that was the assignment for last week. Was there any question, any particular challenge that you want to go over? Was this, so yes.
Doing the delete part, it came up with, I got around it, but it was saying that like you might not want to do this because you're not deleting on
Yeah.
a,
Right. Yeah. So it's making sure that you know what you're doing, saying that it would expect that you're removing by primary key, right? So you know exactly what field you're removing, and anything other than that is warning you that you will be removing more than one, right? So if you do a foreign key or you're doing any non-key field, it says, well, you might be removing more than you think you're removing. So it's just warning you. Just like if you leave out the where clause, right? It would also say you're about to remove all the records on your table. Are you sure you want to do that? So yeah, and you can, there's a flag that you can turn off that it will let you let them know that, yes, I know what I'm doing. Yeah, other than that, I think it was self-explanatory. Yes. All right, I do want to cover the material for this week. So because there's some limitations on what you can do with plain old SQL, right? We want to introduce the mechanism that would allow you to program the database, right, with a full-blown programming language, right? And that's the what we call store procedures, right? So let's talk about store procedures. So yeah, so there are limitations on what you can do with just plain old SQL. We want a full-blown programming language to create functions that we can run. Just like any programming language, you have mechanisms to create abstractions, right? That you have an algorithm or some script that has multiple steps that you would like to just encapsulate and give it a name so that you can just run it by its name, and maybe even parameterize it. You can pass it arguments, right? And it can adapt its behavior, right? Now, the pro of using this is that definitely it's the most secure, right? It's running right in part of the database. It has direct access to the database, right? So there's no need to go through a network. It's as close as possible as an algorithm being close to the data that it's going to operate on, right? Now that's a good thing. It could also be a bad thing. It could you're adding more burden on the database. Now the database not only just hosting data and answering queries and updates and deletes, it's also running programs, right? It's running algorithms, and it's taking away CPU time that it could be answering queries. Yes. There's more to maintain. It's a brand new language, right? You have to test this. You have to hire people that know how to do this, right? And so there's more things to learn and test and everything, right? More things to maintain. Now there are three different types of programs that we would run, or three types of algorithms that we run. One is functions, and they behave just like any functions you would expect, right? It has a name, it has a parameter. You pass it some parameters, some values, and then it runs some query, some algorithm, and it comes back with a value, right? Like a function. And then that value that comes back from the function, you can use it as part of a select statement, for instance, right? Or as part of a where clause. Where so-and-so is logged in, and logged in means whatever, right? Or and where blah blah, certain blah blah has bought from me so and so many products, right, in the last couple of months, right? And I want to give them a discount. Yes. So that function can calculate whether that person is a preferred customer, right? And that they have purchased in the last couple of months, right? And can compute that for you. So that they're meant to be used as part of a statement. Okay, they're meant to be used for that. They always return a piece of value, a data. It can return a single value. It can return a scale. It could be a vector. It could be an array of values. They don't return a table. They don't return rows, right? They can either return a single value, like a string, a number, or it can return an array of values, but not a table. They don't change data. They're only read-only, so they only can read value, do select statements, calculate something, right? But they can't update any value. You have store procedures, which is basically scripts, right? Some you might find yourself doing a lot of, I'm going to do a whole bunch of selects over here, and depending on the result, I'm going to do a whole bunch of inserts, and then a whole bunch of updates. You could, if that's something that you do every morning, you might want to take all those 4 complex selects and inserts and updates, put them inside of a script, give it a name, and then you can just run it, right, every morning, as opposed to having to, execute them one by one. They're meant to be executed at the command line, right? You can give it parameters, right? They they can change data so that you can put in there a whole bunch of inserts, updates, deletes, right? You can make a script out of it. They're not meant to be used as a function, right? Where you expected some value to be used in a larger expression, right? They're meant for you to automate processes, right? Then there's triggers that they're, by far the more interesting ones that, you can configure them to execute when certain events occur, right? If somebody, it can monitor whether a table is being updated or inserted or deleted, right? If something's happening to a table, you can say, right, if somebody inserts into this table, then I want you to do this, right? Maybe, if somebody is unregistering and they're leaving the company, I can go in and change their roles, right? I can remove them from being an administrator and remove all the privileges and whatnot. Yes, I can have that script run, if this person is no longer working for the company. I can automate that, right? Or an audit, I can say, if somebody's modifying some account, right, and I want to keep an audit, right, that somebody deposited or they withdrew from a particular account, I want to keep track maybe of all that activity, right? And so every time somebody does an update on their balance, I'll keep track of an activity. I'll do an insert into an activity table that says, oh, this person, deposited and withdrew and transferred and blah, 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 right? I keep an audit of that. So yeah, triggers can listen in for all those changes. So let's take a look at the easiest one versus functions. So functions, you can create them using the statement create function and the name, and then a body, right? There'll be a begin and end, and then you have code between the begin and the end. Yes, right? The functions can take optional parameters. So to create a function, it's easy. You can, from SQL, MySQL, you can create a function just on the DB design here. Down here in the functions, you can say right click, create functions, and then you can type in the function in here. So you can create something as easy as add 2 + 2, and it returns 2 + 2. Finish. And once you have that, you can then just run that function. Add 2 + 2. And it comes back with 4. Okay. But then this value 4, you can put it as part of a where clause, right? Select, X, Y, Z, whatever from where, right? Some value is equal to add 2 + 2. Right now you can compare that as a calculated value. Now if you notice the actual apply, let me create another one. Function. So add A + B can take A as an integer and B as an integer, and this returns A + B. So when you apply here, notice that it creates the following. So this is what is being sent to the server for execution for actually creating the function, right? And it's basically what you would type at the console, right? If you were using just plain old MySQL, right? Notice that it's saying that I'm using this particular database. Notice the semicolon at the end. See that? That's important. See the semicolon at the end? Semicolon means execute this right away, right? Do this right away. It executes. Then it says drop this function if it already exists, right? So meaning if there's already a function with the same name, just throw it away. I'm redefining it, right? And notice the semicolon at the end. See that? So it happens right away, right? Now notice the delimiter $$, right? What we're going to do here is that inside of my function, I'm going to have a whole bunch of SQL-like statements in there, right? Maybe I'm going to do a whole bunch of selects, maybe some inserts, some deletes, right? Some updates. And I don't want them to execute right now, right? I am postponing that execution for later, yes? I want it to execute later when I run the function. Make sense? Right? So if I put a semicolon in there, in my inserts, in my updates, in my deletes, I don't want those semicolons to be interpreted as executing right now, yes? I want it to be postponed for later. That's why we're changing the delimiter, $$. What we're saying is that no longer interpret semicolon as in execute this right now, right? Right. So if you see a semicolon, it doesn't mean to execute it right now. Right? That's basically what we're saying. Then we create we say use db design $, right? Means that the new semicolon is $. Mean do this right now. Use the database cs5200 now. Now we're going to do create function yada yada yada, return integer, begin, return a comma a plus b semicolon. I don't want it to happen right now. This is going to happen later when I run the function. And $, meaning boom, declare the function now. Now the function is declared. Delimiter semicolon, meaning go back to the original interpretation of semicolon. As and reinterpret semicolon as the execute now. Make sense? Right? Not that this matters much. It's not something you're going to be doing much if you're using these kind of user interfaces, but you're going to find a lot of code that uses delimiter, and you can use any new character here. Since $$ is not a very common set of characters, right? You use a set of characters that's uncommon, like $. You could use // or any other sequence. Apply. Okay, I have those two. Yeah, I mean, SQL has been around for so long. It's very legacy. Yeah. 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 So yeah, add 2 plus 2. So here's a plus b. A plus b. Here we go. So for instance, here we have presumably a table that has A and C, and here we are creating a brand new, on the fly, adding A plus B, and it's just adding these two together. Or the output could be strings, right? We looked at numbers, but it could certainly be strings instead, and you need to declare it as return varchar. Yes. No, that's one of the cons. That's one of the cons. And so vendors will try to sell you a lot. They will try to upsell you the fact of using their particular set of functions. A lot of these functions are pretty standard, but they'll have certain functions that are only available from that vendor, and obviously touting better performance and better this and that and the other. And because typically they would want you to make it as hard as possible for you to migrate elsewhere, right? And because porting all this to a different vendor is nightmare. Especially stored procedures, functions, because a lot of times the syntax is not the same. You have to rewrite them. It's a huge undertaking. So the more they can try to keep you within their particular as a client. Most people will use this that is very specific to the database, but most application level code would be outside of the database. So they would only be using here administrative things or maintenance scripts, or like for performance or for triggers that maintain materialized views. But most of the logic would be outside of this. It would not be part of the database. Like using Java or C# or Python for doing application level logic.
Sorry,
Mostly for maintenance purposes. Like DBAs will use this quite a bit for maintenance purposes or maintaining materialized views, things like that. As in, I like to run in the morning a health check, right, and make sure that all my indices are calculated. That you know, it can run a stress test, see how network connection is, and you know, how sparse a certain table is. Lots of empty nulls. So you know, things that would be useful for checking the health of the application of the database. Usually not part of the application itself. The application logic would live outside of the database, unless you know, creating the materialized views that I mentioned earlier. That would be a very specific performance use, right, where you would be creating redundancy because you want performance. Right, that you could certainly just have a view, a normal view, and that's completely portable between vendors. You know, views are pretty well standard that can be easily ported between vendors. But materialized views means that you can have a whole bunch of triggers, a whole bunch of logic to maintain that materialized views, and so now it makes it harder to port, you know, just the materialized views between vendors, right? And because you would also have to port not only that table, but also all the logic that supports that table, right? And that's where the complication begins. Sorry, yeah. Yep. Okay, so right, so the return can be also just strings. So yeah, those are functions. Store procedures are scripts that you would try to automate, the things that you might run every morning. That you know, perhaps check the health of the database, or you know, something that it might be a batch that runs, you know, every morning or runs at the end of the day, that does you know, checks to see if the balances of the accounts are match, right? It might be a batch transactions that might, you know, at the end of the day, you have all these deposits, and then at the end of the day, you run a batch to make those deposits go and make them permanent, and something that you would run maybe at the end of the day, or you could also automate this, right? It could be run on a timer. You could say, well, at the end of the day, this runs and makes this happen. So anyway, so now in the functions, you cannot change data, as opposed to in store procedure you can, right? So here totally you can do updates, inserts, deletes, which you cannot do in plain old functions. So here it would be, you know, within the begin and the end, you could totally have, you know, a while loop where you have a whole bunch of inserts, a while loop where you can create, you know, a lot of dummy data. That this is also used for a lot of like testing purposes, where you know, if you have a development environment where you have very little data, you can run a script that can generate tons of dummy data, right? Where you can have now thousands and thousands of records with test data that you can run, you know, for your local application. It has the kind of the same syntax, right? But instead of create function, it's create procedure. It has the same begin and end, right? The same $sign delimiter issue, right? So but you execute it not as part of a select statement, not as part of a where clause, but as a call, right? You say call from the command line, right? As opposed to a function is not meant to be run from the command line. But store procedure definitely from a command line. Now in SQL, it's in MySQL it's call, but in SQL Server it's execute, right, or exec. And different vendors have slightly different syntax on how do you call this. In MySQL, you have to provide the parentheses. In other vendors, you can drop the parentheses. So it's slightly different, the syntax. So just, you know, check with your particular vendor on how to invoke the store procedures. It's slightly different. So from here, we're doing a query. Notice that in this case, we are calculating an entire table, right? A result set, including rows, lots of columns. Something you cannot do in a function, right? Functions need to calculate a scalar value, right? Or it could be an array, right? But it cannot be an array of arrays, right? It cannot be a whole bunch of rows. But in a stored procedure, it's fine, right? So it returns the a table. So here's another one, and where we are now accepting an argument 3000, right? So it's retrieving all the users with a particular salary greater than some parameter. Yeah, so different vendors have slightly different syntax. So just check, for MySQL or Oracle has also slightly different, but more or less they're equivalent. If you want to change the a stored procedure, might as well just drop it and redefine it, right? Or you can alternatively use the alter. I've literally never used alter. I've always just dropped it and just redefined it. The right. So if you do want to change it, right, you can say alter stored procedure, and it literally adds the drop as part of the alter. Parameters. So parameters, if you remember from programming, right, typically when you pass a value to a function, that value is either is passed by value or passed by reference, right? And it means whether that algorithm has access to the original value of the variable you're passing, right? Obviously, if you're passing a little string or a little integer value, obviously you're passing that value, right? But if you pass a variable, right, the question is whether that algorithm has access to that variable from within the algorithm. Yes, and you can control that. Now, in most programming languages, you only have two types of control. You can either say pass by value or pass by reference. Some languages always pass by reference. Some languages always pass by value. If you want the other option, you need to use other syntax. So, for instance, Java always passes by reference. C passes by value. And if you want to pass by reference, you have to put like a referencing, an @ sign, and you need to dereference it with a star or whatever, right? So each language has different syntax on how to deal with this. In stored procedures, there's a third option. There's a pass by value, pass by reference, and there's an out, right? So it's a little bit different. So in is the equivalent of pass by value, right? Where if you're passing a variable, you just get the copy of that value of that variable. You don't actually get reference to that original variable. And the in out is the equivalent of pass by reference, right? Where if I pass you a variable, whatever you do in the algorithm, you are changing the original value of that variable. Okay, so it's passed by reference. But you also have the out option, where if I do pass you a variable, it doesn't matter what the original value of that variable was, it will be ignored, right? It's only meant to generate an output. It's for the internal algorithm to set the value of that variable, so you can then read it from the outside, right? Which is almost like pass by reference, right? Other than we ignore the input, okay? So yeah, so just a couple of really quick samples of this. So here's using in. Here I'm using session variables. So these when you put you can declare variables at the command line, and you can say @ and @ means this is a variable that will live throughout as long as I'm logged in. As long as I'm logged in, this is like a global variable that I'm declaring, right? And within my session. So it's not a variable that other users can see. It's only within my login. So they're referred to as session variables. So I'm setting A to 1, 2, 3, and I'm looking at the input. I'm looking at the value. It comes back with 1, 2, 3 over there, the first one over there. But then I'm passing my session variable. I'm passing it to my store procedure over there. And notice that the parameter variable was declared as an in. See that? In, meaning that this is a pass by value, right? So B over here gets the value of 1, 2, 3, And even though here we're modifying B, I'm only modifying the value 1 to 3, to 124, but the value of B, my original variable is not unchanged, right? So I can't change it. Right? So I don't have a reference to at A. It's still the original value 1, 2, 3. Make sense? And that's what we know as pass by value, right? That's the behavior pass by value. In the in out, if I do pass A, if I pass A 1 to 3, now B is not the copy of A, right? Instead, it's A. Whatever I do to B, I also do to the original variable, right? So it's kind of like I'm dereferencing, and since I'm incrementing, notice I'm also changing the original value of the original variable. See that? Which is what we refer to as pass by reference. Yes. There's a third option, which is out. That if I do pass the value of A, right, B, it's the original value of B is ignored, but I can use it to generate an output. I can say B is equal to 3 to 1, right? So whatever you pass me, I'm modifying the value, right? And I get the original value as an output of the stored procedure, right? That's the intention of that value. If I try to use it before I set it, right, it would be null. Okay. Variables. This is just more examples of declaring internal variables. Obviously, we can declare parameters, but I can also declare internal variables. Oh, yeah, so just a couple examples that I can, store procedures can do updates. Yes. Well, when we did the, add A plus B, instead of returning it as a result, right, I can set a value C. That would be an out, and then C would be A plus B, right? No, we would use out for C. Right, so A and B would be in, and then C would be an out. Right? Yeah. And then you would say C is equal to A plus B. And then from the outside, you can get the value of C. Yeah. So here's an example of being able to update from within a store procedure, which I cannot do in a function. Right. So I'm setting, for instance, the role of a particular student, a particular person or faculty, right? I'm setting their role to be faculty. Here, I'm giving everybody a raise. Or actually, no, of a particular user, particular faculty, a particular employee, and I'm giving them a percent increase. So I'm setting the something that I would otherwise type myself, right, at the command line for updating, right? It's just so much easier if I can just wrap that inside of a store procedure and then run it as if I just ran a function. Yes. Yes. I'm sorry. The default is in. Yeah, if you don't say anything, is the default is in, pass by value. You can declare local variables like any function you would expect, right? That they only within the store procedure or within the function, and they disappear afterwards. You're using the keyword declare, the name of the variable, the data type, right? Any default value, right? So here's an example of declaring a couple of integers, varchar, timestamps, and tiny ints that I can use internally for select, just to make sure that just to check to see that these variables that I might declare internally, right, only exist within here. We can see the values every time we run. var2 is reinitialized, recreated, and only exists inside of the store procedure, whereas var2 over here is a session variable, which is kind of global to my session. And if I change it every time I run this, the value increases every time, 2, 3, 4. But the local variable is always starts at its original value of 1, and then it just increments to 2, right? But then it gets thrown away, and then it gets redefined. Okay. Conditionals, you can have internal if statements, obviously, and the same case when that we looked at earlier, right? That where you can have if else, right? Here we are checking to see a particular variable. If it's one variable, we do a select. Otherwise, we do some other select, or we do inserts depending on a particular variable. Depending on that value, we do an insert or another insert. So that's pretty cool, right? Because the operations in other programming languages are, are either arithmetic operations or operating on your particular data types, which are strings, arrays, objects, right? Classes and whatnot. Here, the fundamental data type that you are operating on is the tables, right? You're retrieving from tables, you're updating tables, you're inserting into tables. That is the fundamental data types that you're working with, right? As opposed to in other programming languages, you're always thinking about objects, instances, right? And how to manipulate those using dot notations and methods and whatnot, yes? Whereas here, the fundamental data type that you're manipulating are always tables, right? Retrieving from tables or inserting or updating. So here we're doing all these whens and whatnot, or if statements that you're doing inserts or updates or deletes and whatnot, yes? Loops, you can, there's 3 types of loops. You can do a while do, meaning you don't execute the loop unless the predicate is originally true. You don't enter the loop, as opposed to a repeat until, right? It executes the loop at least once, right? As long as the predicate is still true, right? This is the same as a while do or do while in other programming languages. The difference is obviously is that what you operate on is tables, right? And so this was while loop, for instance, is iterating and inserting a whole bunch of values into table 1, right? As long as the predicate is still true, right? And this one just keeps updating the value of set as a counter until it reaches a repeat. You also have a loop. This is kind of like the break and the continue in other programming languages where you can put labels, right? And then you can break to that label, or you can continue to that label. Same thing here, right? You can do iterate and you can jump to a different label, or you can have any number of labels, right? That you can loop to, or a break. So leave is kind of like break, and iterate is kind of like continue, right? So triggers, I think, are the most interesting ones, right? That allow you to put a listener on changes on specific tables, right? You can say, hey, if there's if there's an insert or an update or delete on a particular table, notify me, right? I want things to happen, other things to happen, yes? So for instance, the general syntax of a table of a trigger is that you give a name to the trigger. You specify also when does this happen? Does it happen before the event or afterwards, right? Whether should this run before the insert or after the insert, right? Or before the update or after the update. Okay, and the trigger event is whether it's an update, a delete, an insert, update, or delete, and then you can be notified on whether this happened on a table, or if you want to be notified for every single record that was affected. Okay, so how many times do you want to be notified, right? If somebody inserts 3 records into one table, do you want to be notified once, or do you want to be notified 3 times? Do you just want to know that something happened to the table in general, or do you want to know all the details about every single insert, right? Or every single update or every single delete, right? So the naming convention, or I mean, you can call the triggers anything you want, but a very common way of naming triggers is to specify the trigger time first, before or after, then the table, right, on which the trigger is being defined, right, and then the event at the end, right, whether it's an insert, update, or delete. So for instance, you might have before employee update. Okay, just some common names. So here's an example. If you had a table where you want to audit things that are happening to employees, whether I've given them a raise, whether I've changed them from one job to another job, or from one place to another, and and I want to make sure I keep track of what's going on with every employee, right? So I want to keep track of the employee number, last name of the employee, when did this happen, and what was the action, right? Whether I gave them a promotion, or whether what happened to this employee. So here's a trigger, right? You can say create a trigger, and the name of the trigger would be before employee update, right? So the key, then the way it's declared, it says, before updates on employees. So declare this trigger before update on employees, and I want to be notified for every single row, right? Every time there is something happening in this table, I want to know every single row. I don't want to be notified, if there's a whole bunch of a batch of inserts, I don't want to be notified once. I want to be notified of every single one of them. And then there's a begin and end, right? Now in triggers, in triggers, you depending if you are running before or after the fact, right? Like before the insert or after the insert, there's an additional keyword that is available to you, right? Which represents the record that is being affected, right? So for instance, I can say, well, if you're updating a record, I can take a look at the record before it gets updated, or I can take a look at the record after it has been updated, right? Or same thing in the insert. Before the record actually makes it into the database, I want to look at that record, right? And I could maybe veto it and say, no, I don't like this record, right? It's missing this, and the date is wrong, and that's way too much salary, or whatever, right? And I could take a look at the record that is about to be inserted, and I can veto and say, no, I'm going to abort this. I'm not going to allow the insert to go through, right? Or I can modify the record, right? Maybe fix a couple of things. It's missing a date. Maybe I can initialize it, right? It's missing a couple, or maybe I need to do some query. It says, oh, I don't like this value. Let me go do some query, do some calculations, come back, and then give you the actual values I want to use. Yes. Now that I have my brand new record I'll go ahead and make it go through. Yes. Right. So that's pretty cool, right? I could have triggers that can fix things that it would normally make the database fail. Yes. Because I can calculate a couple of things. Maybe because of the domain that you're in, or maybe I can imply or infer certain things based on certain data, right? So here it is. So I'm going to because somebody inserted into the employees table before the update. I'm sorry, no, somebody updated into the employees table, right? And this is before it gets updated. I am going to insert into my employee audit table, right? I'm going to insert into my audit table, and I'm going to set the action to update the employee number. I'm going to look at the old is a keyword that is referencing the old record, right? The record that was updated, right? That that it's about to be updated, right? Hasn't been updated yet. Hasn't been updated yet. And I can read values from that for what the record used to be. And I can take a look at grab the employee number. I can grab the last name from there, right? I can get the change data, and I'm now I'm inserted into the audit table that this person has been updated. Maybe the salary went up, or whatever, right? Or if it's an insert, I'm inserting a brand new employee. I can now the keyword new is available to me. That is a reference to the record that it's before insert, so it's about to be inserted, right? The record is about to go in there, and so I can take a look at the new employee number, the new last name, right? Notice that I would not have access to the primary key, right? If this is auto incremented, right? If it's an auto increment, I would not have access to the primary key, right? Only in the after. I could have another trigger that is instead of before insert, it would be after insert, right? So after insert, yes, I would now have access to the primary key, right? Because it has been auto incremented, right? But not before. right? But hasn't made it into the record yet, right? Into the database yet. But here I'm copying over some values from the new record that's being there. Yes.
If it was an update, would you have access to the primary key then, since it's already been?
Yes. Oh yeah, of course. Yes. Yep. All right, I'm not going to do the demo. Let's take a quick break and then we can talk about the exam next week. Yes.
The database versus the backend thing, the backend logic. So the kind of update that we're talking about, insertion.
Oh, okay.
What that would be a good idea that as we see it now, database side versus with that logic. The backend thing,
Yeah. So usually if you have an operation where you are updating multiple things, right? That you might need to be in a transaction. For instance, say I'm transferring money, and that transfer means that I need to update 2 records, right, or 2 tables maybe, where I need to do a withdrawal over here and then I need to do a deposit over there, right? Where one operation needs to be split into 2 inserts and an update, right? Usually those kinds of operations you want to keep it inside of the database where you have full control of the transaction. You can begin a transaction, end the transaction. You can easily commit or roll back. That kind of operation is easier to maintain those in part of the database and like triggers. And it's actually discouraged to do things like that on the application level. At the application level, you can still do it in the application level, but all that nitty-gritty, really low level things are better kept under the application level. Is usually for more business logic that might need enterprise level logic, right? Whereas low level stuff like breaking out several updates into multiple updates and wrapping them in transactions and things like that would be at the database level. And then maybe you can expose it as a function that can be executed from outside, right? Because usually program managers can also not only send flags and inserts and updates, they also send execute this sort of procedure, right? Or execute this whatever from outside because at the database level it's like programming almost like like assembly. It's like very low level, and whereas you want to keep object orientation and hierarchies and all these advanced new paradigm programming components, injection and version of control, all these things are completely foreign in the database world. Right? You want to create that separation of layer of abstraction of your application language, and as opposed to the database language. Yeah. So all the nitty-gritty, leave it at the database level. With all that, what implies that if you're going to port this at some point, right? You're going to port this to some other vendor, but usually it's going to have that much better performance. Breaking it that way. Yeah. Yeah. True. That is true. Yeah. And the whatever compromise whatever compromise the team is willing to make. Well, actually, a little bit when we talk about ORMs, observational mapping. We'll talk a little bit of that. Where the application language makes a huge effort at hiding tons of stuff that's happening. Well, yeah, we'll talk about that. Yes.
Is course for next week with exam 1?
No. Oh, it could be. You give me a great idea. Oh, that'd be perfect.
No, right? We just have the midterm.
Yeah, only midterm.
And the course for will be.
I guess so.
the
Then we'll
next
come back.
week.
Yep.
And we wanted to put the exam date for the finals as well. Just a tentative idea, maybe something.
I think that's the 12-13.
So I booked the text for the interview.
Okay.
Is it possible to take it earlier?
Not earlier. Could take it afterwards, like day after a
From
24-hour flight.
From there. So it will be around the 13th
Yes.
of December. Okay, that'll be the last day of the class.
Yes.
And by then we'll be done with the project and the submissions.
Correct.
Okay. So if I had to request for
Yeah, I mean, yeah, just like these folks are logging in, I'm gonna start a chat. I'll start a Zoom that night. And if you're not here, yep,
Thank you.
sure.
Yeah. The first way, I don't know Python, but in the just like copy it, put in there, so like copy from online, but instructions that don't. He's like, I don't know what to do. I'm like, actually, there's something you don't tell them what you did, but do it. And we're going to do it, hold on that thing. Understand it and make sure you can write it on your phone. And then it's like, actually, that is right. And then he did. Oh, he did. He did. Okay. Like, I don't know if it's using that song. Yeah, already. Or embedded software. I don't know. I don't know. That's what embedded software. You know what that is? I know you guys are computer engineers. Stuff.
All right.
I wanted to yeah, we do computer science stuff. No, just wanted to read. Ask me that. And then like, and then he was like, oh, okay, this was it, I did.
All right. Let's take a look at some midterm. All right, let's talk about just some sample questions you might expect at the next week's exam. There will be quite a few grouping questions, of which these are representative of those questions. Some of them will be fairly trivial. So here's one, right? There's giving the following schema. We have orders, and you have these 3 fields: customer, order date, and order price. Usually the schemas I'll give you won't have data types, although oftentimes they'll be self-explanatory, whether they're a number or a date, right? And so in order price, if it's not self-explanatory, ask me, but I think price is, I think it's self-explanatory as being a number, right? And order date being a date. So the question is, I'll give you several options for you to choose the implementation of the following query: the sum of all orders per customer, right? So usually the per customer is a giveaway that you're going to be grouping by that field, right? And usually the sum or whatnot is also a giveaway that you're going to be doing some kind of aggregate, right? So usually I'll give you 4 options for any multiple choice. Usually 2 of the 4 choices are obviously wrong. You can immediately just drop them off and not even consider them. The other two usually are like very, very close, and you're kind of like squinting and understanding what the difference is. But obviously there's only one correct answer, right? If there isn't, point it out and we'll fix it. It's wrong. Unless I tell you, select all that apply, then yes, there might be more than one correct answer. So here I've highlighted a couple of reasons why I didn't choose those answers. The last 2 are obviously wrong because they're grouping by the order price, right? So that makes no sense, right? We want it by the customer, right? So it needs to be grouped by customer somewhere, right? So notice that the first 2 do group by customer, right? So then we need to choose, well, why one or the other? And notice that both of them have the aggregation of summing the order price, right? So that can't be the difference, right? The only difference seems to be in the select clause. One has customer and the other one has customer and order price and order date. Okay, and it's kind of asking you, do you know or do you remember that in the select clause you can only have either aggregates, right, or whatever you grouped by, right? And we group by the customer, so the customer is fine. We can leave that in, right? But certainly not order date, because we did not group by order date, and we're not aggregating the order date, right? So the order date cannot be in there, and that's why that one is wrong, right? So that we keep the 1. Yes. So there'll be a couple of those, right? So make sure you understand. Some of them will be wrong because it's got the wrong thing in the select clause, right? It'll be wrong sometimes, especially if you have multiple tables, right? It'll be either missing the table. I'll show you some examples. Here's another question, says, how many orders per product? So notice that this one was a single table, right? This was a single table, whereas some of them could be multiple tables. And multiple tables, you have to have a way of relating the two tables, right? In this case, we have both of them have primary keys, but orders has a foreign key. See that? And notice that I deliberately put a in parentheses PK or FK, and usually the foreign key, the name of the foreign key will be the same as the primary key of whatever it's referring to. Okay, I'll make sure that it's unambiguous what is referring to what. Okay. So the question here is, how many orders per product? So per product already it's kind of telling you that you need to group by the product. Yes. Now, not always, even though it says to group by product, not necessarily do you need the product, right? Even though you have two tables here, notice that we could group by the product just with a foreign key in the order table, right? Not necessarily do we need to join with the product table, not necessarily, unless this would say, and the name of the product, right? If this says, tell me the names of the products that blah 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 blah, then I do need the name of the product. So I do need to join, right? Because the name of the product lives in the product table. So I have to go fetch the product name from the other table, right? But even though you might have two tables, not necessarily you need to join, right? Only if I'm asking information about that other table. Yes. So here we have again I replicated here the schema, and again I've highlighted the reasons why the other ones are not. I didn't choose those. Notice that they all group by order dot product ID. See that? Right. So that definitely can't be the reason why I chose one or the other. And so they're all grouping by the same, right? Group order product ID. Notice that it's only looking at the orders. It's not even looking at the customer. Sorry, not looking at the product. It's not even looking at the product. It's not joining into the product. Even though I gave you two tables, you only really need one. So you were grouping by order ID. Notice that in the from clause, they're all the same, right? So definitely that's not why one or the other is different, right? Or wrong. So it must be something in the from in the select. So let's look at the select. So notice that in this one, right? Notice that I have in the select I have order date, right? But again, in the select statement, you can only have things that you have grouped by or that you're aggregating. So you cannot have the order date. So that's wrong too, right? These are wrong. Actually, what's the difference between the last two? Count. I think I meant to do a different count here. I think I meant to do a PID here. Yeah, I think I meant to do a PID just like this one over here. This one here is counting the product ID instead of counting the order ID. But they wanted to how many orders. I want to count orders. I don't want to count products, right? Because an order could have multiple products, right? So if I could end up counting many more things than I want to count orders, not products. Right. So yeah. So that's the wrong count. I want to count order ID, and I can only put in there in the select statement only things that I group by. Okay. So here's another one. A question. Oh, yes. Yeah, it would be the same. The thing is that then you have to do the join. Yeah. Which here is irrelevant to do the join because you already have the same value in the order. So here's another one. We have students and major. It says, what are the min and max graduation year per major? Again, do I need the other table? Probably not, right? Notice that the graduation year, I can grab it from the students table, and the per major, right? I also can grab it by the foreign key of the major ID, right? Unless I would be asked, and also give me the name of the major, right? You know, for each major, tell me the minimum and maximum year. Then I would need to do the join, right, of that foreign key equal to the primary key, right? So here's the a couple of examples. So here I'm doing the join, even though I don't need to do join. I am grouping correctly by the major ID, right, which is fine. The join is fine, right, but I don't need it, right? And notice that I am doing the join because I want to display the major name, even though I wasn't asked for the major name, right? And anyway, I could not put the major name anyway because I did not group by, right? And I can't aggregate it, right? So even though the query is correct, that I am retrieving the correct major, the correct major record, so that I can extract the major name, I cannot put the major name because I did not group by it, right? So this one, notice that I'm erroneously using aggregation in the where clause. I can't. That's a wrong syntax. I cannot put aggregation on the where clause. I can only put where aggregation on the select statement, not on the where clause. That one, the group by is I'm not aggregate. I was asked that I want to have per major, not per year. Over here, I'm aggregating by year, right? That's not what I was asked for. And finally, although the aggregation is correct, right? I am aggregating the graduation year, min, max, that's good. But I am grouping by the wrong field, whereas in the top one is correct because I'm grouping by the major ID and then only aggregating the min and max year. So here's another one. So here I'm giving you a little more interesting database, the school database. I often use these, you know, like the same. I usually choose a theme for the exam, and then I use that theme throughout the exam. Sometimes I use the school, sometimes I use airlines, stocks, or different. It changes from one time to time. They're usually the same structure though. They usually contain at least one to many and at least one many to many, right? So here's a one to many. The enrollment is a many to many, right? So here we're asking, you know, referring to that school database, I'm going to give you 4 answers that implement the following, right? So I'm asking you, you know, given this question, which of the following queries implements this question, right? And the question is, which students got the highest grade in a course titled CS1234 in the semester of spring 2345? Okay. List the student's ID, first name, last name, and final grade. Okay. Okay, so we need highest score in a course, right? So highest grade in a course. So let's see, we have a department that has many courses, and one course has many sections, and then students are enrolled in these sections, right? Enrollment says which students are enrolled in which section, right? And then we have the zip code for each student, and they're asking us for what? So the highest grade. Okay, so where are we capturing grade? Looks like the enrollment is capturing the grade. Okay, so we definitely need here something. We need to grab all these values from the enrollments, not all of them, some of them that meet some criteria, and we need to calculate the highest grade. So there'll be some grouping of which we're going to do a max in that grade, yeah, in the enrollment grade. Okay, so highest grade in a course. So that means that that we need to have a bucket in a course, right? And somehow a whole bunch of things are gonna, a whole bunch of grades are gonna fall in that bucket, and then we have to identify the max, right, of those. And then presumably there'll be another bucket of, again, some other course, I guess, right, with a whole bunch of grades for that course, and we need to find out the maximum of that, right? So it'll be a whole bunch of buckets, and each one will be max grade, max grade, max grade, max grade. Right? So highest grade in a course titled CS1234. Okay, so it's not all the courses, right? It looks like we are talking about a specific course and for a specific semester. Okay, so spring 2345. I guess you could have the same course multiple semesters, right? But it's a specific semester, and I guess you can assume, I bet somebody asked me that, could you have the same course in the same semester twice, right? And so now you can, each semester you can have the course only once. You can have multiple sections of the same course, but that course is only once per semester. And so there'll be somewhere there'll be some kind of where clause that says that the title of the course is CS 1234 and that the semester is 2345. So the title lives in the course table and the semester lives in the enrollments table, right? So somewhere in the where clause, we need to make these things. So because the title lives up there and the enrollment lives up there, the only connection between the two is the section, right? So we'll need to join those three tables, right? We'll have to say, course CID is equal to the section CID, right? And that the enrollment section ID is equal to the section ID, right? We'll need to join these three tables. So there'll be a join that joins these three tables, and also there will be an and. Course title is equal to 1234, and enrollment semester is equal 2345, right? So there'll be a big where clause that does the join and does the filtering. Make sense? So presumably that puts the in that bucket of CS 1234. I guess it'll be just one bucket, right? There'll be a single bucket for the course CS 1234, of which there might be multiple sections. There might be a whole bunch of enrollments, which I don't want all of them, right? I only want the ones for a particular semester, right? And so it'll be filtered by this where clause. So this one bucket for CS 1234 will only have the enrollments of 2345, of which the enrollments also has the grades, right? So now that they're in the same bucket, I can do the aggregation of doing the max of grades in that bucket, right? Now these enrollments in that bucket, I also want to put in information about the student, right? Because they're asking for the first name, last name, and all that, right? So here we have the students. So if you can break it out into multiple of these, right? The highest grade, the course title, the semester, the spring, and the students, whatnot, right? Okay. What we could do is that we could first calculate in an inner query. You can first create these buckets, right? And say, okay, well, what is the maximum for this course, right? And create create these the V1 bucket, right? So here's the enrollment section, the section. I'm sorry, the enrollments table, the first one, right? Number A, right? So enrollment sections course student, and there's the first where clause where it joins all of them. So it's joining the enrollment with the section. Yeah, you gotta make sure. Sometimes I throw in sometimes I put the wrong mapping there, the joins. Make sure that the joins are correct, right? Usually it should be easy because I name the foreign keys equal to the same as the primary keys. So it should be easy to check that the foreign key matches the primary key. So notice that E.scid matches S e.scid. So that should be easy to check really quick because I'm following that naming convention. I don't have to follow the naming convention, but I will. Okay. So you can assume that those should always be the same, right? So e.scid is equal to scid. Yes, I'm joining the enrollments with the section. And then I'm joining the section course ID with the course CID. Again, the CID match, right? So that's good. I'm also joining the student SID with the enrollment SID, right? Again, those match. Notice that I'm doing the I'm filtering out the title of the course, and I'm filtering the enrollment semester. That looks right, correct? Yeah. But I'm grouping by SID. That's not right, right? Because remember, we want to make the bucket. Now that creates buckets per section, right? So a course can have many sections. If it has 3 sections, then you have section 1, 2, and 3, and now you have 3 buckets. But we want really a bucket per course, not per section, right? So that's something wrong there, right? So that's not right. We didn't want it by section. We want it by the course. So we should check for that, right? We should check for that. So let's look at the B over here. So B says we're looking for the enrollments, the sections, the course. Notice we don't have the we don't have the students here like I had in the one before, right? So do I really need the students? Maybe I don't need the students, right? Because we had said that we want to join the first 3, right? Join the first 3, the course, section, and enrollment, to create the bucket, to calculate the maximum. Is it maximum? Yeah, the maximum grade. I don't need the student. The student was a secondary question. What students are they, right? What are the students who got the maximum, right? But I first need to calculate what the maximum is. Yes. So that's what this inner query is doing, right? Notice that I'm here. I'm only doing enrollment, section, and course. And so is the are the joins correctly? SCID, yes, SID, okay, and course, okay. So those joins look right. There's a filtering, so that's promising. Notice there's no group by. There's no group by, right? That means that whatever this comes back, whatever records this identifies, it'll be like one big group. Yes, right? And then the whole thing is going to be collapsed, right, into a single value, just looking at the grade. Right? So this calculates the grade, right? And I have identified that one course, because I know that one course only happens once for that semester. It's not like I'm going to have another course with the same name the same semester, right? So this comes back with one value. The value can be calculated against a select statement, right? With the students. The students that that has a grade. Oh wait, that's wrong, right? Because the grade is not on the student, is it? Is it? Oh, there is a grade on the student? Oh yeah, so the student has a grade. Okay, all right, never mind. So the schema is redundant because the grade is being captured in 2 different places, right? So there could be some inconsistency. The enrollment record might say 1 grade, and the student might have a different grade. Also, is this grade like an overall grade? It's the same grade, so that's wrong, right? But nevertheless, we can use that. So yeah, so this one checks to see the grade. So this third one, notice that it's in the inner loop, in the inner inline view, it's looks like it's has the same max, right? Has the same max. It's doing from enrollments, sections. Then it starts joining the enrollment section ID with a section ID, right? And then section course ID with courses.cid, right? There's something wrong there, right? Right, because what is courses? Courses is the name of the table, right? But I can't use the name of the table unless I have it as part of the from clause, right? Notice that the courses is not listed in the from table. See that? So I can't really join it. So right there's a syntax error there, right? Down here, I have something similar. I left out the section table, right? So I can't really join with the section table unless I have it in the from clause. So definitely these two C and D are definitely not what I'm looking for. So the best answer is B. Okay. Then I have question 4, which I am leaving for you to play around with. Yes. Yeah. Yeah. Yeah, right. Because some values are in the course for the title, and the grades are in the enrollment. And the only way is to join them all 3. Oh, yeah, you can use either one. Yeah, either one is fine. Absolutely. Yep. This is perhaps a little easier to read, maybe, but you can absolutely use the other one. Yeah. So in this one says, based on this database, which is almost the same thing, right? It's got just a couple of one-to-manys and one many-to-many, right? And you have a flight, you have airlines on the left-hand side, you have flights, you have reservations in between, you have the tickets that says that this passenger has tickets on that reservation over there, and passengers might have selected a particular cuisine, something to eat. But other than that, it's almost identical to the other one, right? Just a couple of one-to-manys and one many-to-many. So this one says, okay, based on the airlines database, write a SQL query to calculate how many reservations. So there's a count, right? How many reservations? So reservations are those over there. So you're basically you're counting those reservations over there. Were made with Qatar Airways flights for a cost higher than the average cost of all Qatar reservations. So there's a couple of questions here. First, you need to calculate what is the average cost of all Qatar reservations. That's a whole inline, right, view. Right, there's right, where the cost is defined as the cost of reservation is the sum of all prices of all the tickets for that reservation. Right, so you need to identify the reservations for all the same tickets in that reservation. Right, so a reservation can have multiple tickets. Right, there's a family, we're all flying together, we're all on the same reservation, and there's 4 of us. Yes, and the total cost of the reservation is how much each ticket was, right, added up. Okay, so that needs to be added up, and across all the reservations for Qatar, and then you get what the average is, right? So once you have that, so that's one inline. So this is one inline. The average cost of Qatar reservations. That's one inline. And then it says, okay, well, what are the ones Qatar Airways flights cost higher than the average? Right. So again, you're gonna calculate the total cost greater than whatever this inline comes back. Okay. And you're gonna filter by, you only want the ones where the airline is called Qatar. So that's the name of the airline is over here. So Qatar is the name of the airline that has a whole bunch of flights for that reservation. Right. So I'll leave you that one to play around with. You won't be asked to write a query. Right. You won't be asked to actually write a query. You'll be given a question like this. I'll give you 4 options. Which of these 4 options implements this best? Okay. Or a fill in the blanks, right? Where you have to choose what am I grouping by? Am I grouping by this or am I grouping by that? Yes. Okay. Yeah. There will be a couple of normalization questions. First normal form, second normal form, third normal form, right? And they're all about. They're all going to be something like, here's a database, right? I'll give you a schema, a starting schema, and then I'll ask you, what's wrong with the schema? and it says, does it break first normal form? Does it break second normal form? Does it break third normal form? Okay. And then I'll say, well, what's a better implementation, right? And so if you identify that it breaks second normal form, then usually the solution will always be, for most cases, almost every case, you have to split, right, the table that I give you into 2 or 3 tables, right? And so the question will usually be, well, here's a query, tell me what it breaks and what's a better implementation. I'll give you 4 options, okay? And usually all of them will be a break of the tables, okay? But you have to maintain the same logic that was in the original table, right? And the fact that you identify that it breaks second or third or first normal form will give you a clue onto which one do I mean. Okay. So here's a first one, almost straight out of the slides, right? Where you have three folks that you have one single primary key, and we're capturing the telephones in a comma separated or semicolon separated set of strings, right? And we said that that's a no-no. That we said that it breaks first normal form. We don't want a field to capture multiple pieces of data. There should be a single piece of data. And if you remember in the slides, we went through several options. What is a better implementation? Should we have multiple columns, one for each value, right? So we can presumably scale by adding more columns, but then we don't know how many. Or we can grow vertically, right, where we just add more records, one per each one of the data of the instances of the telephone, right? But then obviously then we have this repeated multiple times, so you have a lot of redundancy. Or this option, right, where we've broken up into 2 different tables, where we capture the telephones in one of them and the users in the other, right? And so you choose A, B, or C, and C here is the result, right? Is the correct answer, where one of them is a foreign key to the primary key from the original table. Again, here's another one that has the first 2 keys are part of a combined or compound primary key, right? Usually those questions are for second or third normal form, right? Where if it's a compound key, usually it's a question about second or third normal form, right? Because usually what we want is that the non-keys should depend only on the whole key and nothing but the key, right? And so this one, if you remember, this one broke third normal form, right? And because you had functional dependency between two fields, right? Where one is the date of birth of the winner, right? Of the I might also say that I might explicitly tell you that there's a functional dependency. It has happened to me that I've used terminology that is not clear that one column depends on the other column. Okay, so like I've used, I don't know, like model and brand or something like that, and because of different cultural places that folks come from, right? And so I will probably give you explicitly column A has a functional dependency in column B, right? I'll say something like B, right? Meaning that there's a functional dependency that if I know A, I also know B, right? And so there's a dependency. B depends on A, right? So I'll say, the winner, the date of birth depends on the winner, and explicitly will say it, right? And so knowing that, then you say, okay, well, if there's a dependency, that this is breaking third normal form, right? So and usually the solution is to break it into two tables, right? Where this would be a foreign key to the, to this table over here, right? But it'd be a separate table, right? So I'll give you different options where I break it up into different ways. And notice that here I have the primary key. The primary key is a combination of tournament and year, right? I do want to keep the same structure as before. So I do want to keep tournament and year together. I don't want to break that, right? So I just break out the person into a separate table with its own date, and then winner is then a foreign key into this winner over here. Okay, as opposed to this one, notice that I've broken up the original primary key of tournament and year into separate tables, which is not what I want, right? I've kind of lost the original structure of the original table. Sometimes I'll throw in something like, it's both of them are correct or none of them are correct, right? Seldom is it that none of them is correct. There might be. There might be a question on relational algebra. There might be a, just a couple of, definitions, right? What's the definition of selects and projects and sorting, right? And, just they're right on the slides, just, would just become familiar where the definitions are, and you understand the definitions, and you can quickly look them up. But you can assume there will be some definitions. There definitely will be a question on using the syntax of the relational algebra, using the functional notation where you have function select, project, and whatnot. And I'll give you a schema, and then, for instance, project. If you remember, project was extracting a field from a result set. So the result set would be the employees table, extracting the name field. This is when you say select name, right? That's a projection, right? So that's what this is doing. So this is the output of that projection is being used as the input of the select, right? So projection filters horizontally, whereas select filters vertically. So vertical meaning select filters which records you want, whereas project filters have which fields you want. Okay, and so the select statement is a combination of those two things. The select where, right? The select where is a combination of the select and projection. Yes. So the when you type SQL at a high level with that English kind of language, it gets parsed. It gets parsed into steps of what needs to happen in what order, right? And you can ask the database, okay, how are you going to execute this SQL statement with a whole bunch of where clauses and froms and joins and blah blah, right? And the database can tell you, okay, this is what I'm going to do. I'm first going to do a projection, then I'm going to do a select, then I'm going to do joins, and then and it tells you with names similar to this. You can ask for a plan. What is your plan? And it'll spit out the sequence of operations that it will execute, right? And they're all based on these very low level operations. So that English kind of language gets compiled into low level operations that look like this. And that the output of one of the operations feeds into an input of the other operation. And it creates like trees also, right? So you can follow along where a bottleneck might be happening, right? And you can rewrite your query to optimize that query. So notice that this inner projection is filtering out all the fields except the name field. Which kind of breaks the outer select, right? Because the outer select is doing a where PID is equal 10, but the inner one is not selecting the PID, right? It's filtering out the fields, right? And it's only keeping the name field, right? And so the outer select doesn't have the PID to run the where clause, right? So this is a the question is, the query is meaningless. Therefore, the query returns nothing, which is the correct answer. Or the names of employees assigned to project whose PID is 10. That would be the case if it would be backwards, right? If this would be a select first and then the projection, then that's true, right? If you invert this and you just select first, you select from employees, comma PID 10 first, and then you do the projection outside with name, then yes, the second would be true. The second would be true, right? Here's another one, which is just using the function nomenclature, the symbolic nomenclature, which is, you remember, pi means projection, sigma means select, and this is the and or, right? Or and, where PID is equal to 10 and hiring years 2004. What does this mean? And then I give you a couple options, right? It retrieves all the employee names of employees assigned to project ID and hired in 2004, which is the correct answer. Joins. So yeah, so I'll give you, 3 or 4 tables that have a whole bunch of primary keys and foreign keys that point to each other, right? So I'll always follow the same naming convention, right? I'll name what are the primary keys, what are the foreign keys, and how they relate to each other, right? And so this one says, so select the correct query that implements, all the technology stocks owned by John, right? So usually I get a question and say, well, how do I know the technology stock is, which one is it? So it's type in this case. The type of the stock is technology, and owned is this owner here. So I give you 4 options, right? It says, select star from stock. So here's the 3 tables. I think I use all the 3 tables. Oh, notice here I'm also only using 2, and maybe I can get away with 2. I don't know. Can I? Well, it says the technology stock owned by John. So owner is here in owner, right? And technology stock, that's a type that's in the transaction here. And all the technology stocks, so it's not clear whether I want the stock or not. If I only join these 2, portfolios and transactions, I'm only retrieving transactions and portfolios. I'm not retrieving the actual stock, right? So it kind of hints at that I really want all 3, right? Perhaps this might be better, if it said, give me the names of the technology stocks owned by John, maybe, right? Then it would be clear that you need to join all 3, right? So, but even the ones that, notice that here I'm joining 3 tables. Here I'm only joining 2, But notice that it's a giveaway that this is wrong because I'm using the name of the table, even though I don't have it in the from clause. So it's a giveaway that's wrong, right? How about this one? It says, I'm retrieving stocks and portfolio, but I can't join stocks and portfolio because the only join between them is the transaction, right? So I don't have the transaction. So there's no way to join these 2. So this is clearly wrong. So I'm left with the other 2 that are joining all 3. So is there something clear that is wrong with either one? Looks like both of them are correct where the type technology is John. So, and they're both declare all three tables, but the where clause seems to be slightly different, right? Notice that a quick check is making the foreign key of 1 equal not to the primary key of the other, right? So this is wrong, right? This is a primary key equal to primary key. That's wrong, right? I need to have a foreign key equal to primary key. All right, same thing here, right? There's a primary key equal to primary key. That's wrong, right? So that's a giveaway that this is wrong. So it must be this first one. And I would just look at it real quick, just to make sure that there's nothing else that is wrong with it, right? So question A. Question 2, probably similar, it says, yeah, all the names of senior passengers booked by Alex. And I remember somebody asking me, what's a senior? Somebody whose age is greater than 65. And booked by Alex. And that's kind of like the booking agent, right? The name of the booking agent is Alex. The passenger's age is here, right? I think somebody kind of telling me that it wouldn't be better to have the date of birth instead of the age, which makes sense. That would have been better, right? And what else? Do I even need the ticket? Do I even need the ticket? So like this, all the names of senior passengers booked by Alex. So it's not clear that I even need the tickets, okay? Because I have the reservation here for the booking agent and I have the age and the right passengers. I might not even need the ticket, right? The ticket has no, oh, unless, wait, no, I do, right? Notice that there's no relationship between the passenger and the reservation. Right? There's no way for me to get from the passenger to the reservation. The only way to get from one to the other is through the ticket. See that? The ticket has both foreign keys, one for the passenger and one for the reservation. So I have to, and since some of the information lives in the passenger and some information lives in the reservation, I have to use all three, right? Okay. So I, quickly now that you know that I'm trying to trick you into missing tables, right? I might do a real quick thing to see if I'm missing any tables in my from, but not this time, right? I'm having all the tables in the from clause in all of them, so that must not be it, right? This looks like there's nothing wrong with the from. So maybe also something real quick that I would check to see if the right? If the where clauses are right? If the joins are right. And usually it's a foreign key is equal to a primary key, not primary key, or foreign key, right? It should be foreign key to a primary key. And the naming convention that I will honor in the exam is that foreign keys names will be the same as the primary keys that they refer to. Okay, I will honor that. Even though SQL doesn't force you to do that, right? But anyway, so real quick here, looks like the primary key is equal to the foreign key. Foreign key is equal to the primary key. That looks right. That looks wrong, right? Primary key, that's wrong. So this is out. This one's out too, right? Same thing here. Same thing here. So okay, not even checking anything else. Looks like the first one is looks like it's right. Okay. Just to check real quick, make sure that the the ages are right, that the booking ages are correct, right? That the where clauses are right. So the joins are right. The filtering is right. Okay. DAOs is not going to be in the exam. That's programming. Okay. All right. That's all I have. What else?
What about the stored procedures?
Yeah, I'll come up with some examples of stored procedures, and probably triggers. There'll be like a trigger question. Okay. Yeah, I'll share something with the triggers. Yes. I'm sorry. Yeah. Usually for a particular topic, you'll have a multiple choice and a fill in the blanks. Yeah. For topic. All right. All right. Any questions? All right. Excellent. Let me go over the assignment. Well, I guess we can go over it next week. So next week, the first half will be lecture, right? And the first hour or so, and the last 2 hours will be the exam. Right? So we'll go over the assignment next week.
Hi, Professor.
Right. So I moved the due dates a week later. So this one's not due next week, but the week after that. Okay. Question online?
Yes. So for next week's midterm exam, can we take exam online at home, or do we need to go to campus?
Right. So if you have a good reason to not come, you're welcome to stay home. But the university has made it very clear that you should be here. Right. If you don't have a good reason to stay home, you should be here. Okay. If I see folks not honoring that, I'll have to stop using, having remote classes. Right.
So if we
So please be here.
Okay. So do we need to bring our laptop?
Yes, you need a laptop.
Okay.
Next, the whole thing will be online, just like a very long quiz, like all the quizzes we have so far. Sorry? You'll know their way right away, yes. But you won't have access to the answers right away. Yes. Yes, the exam is open book.
How much time do we have once we open the link?
The answers to the previous quizzes. Oh, yeah, sure. Yep. And so the first hour or so we'll have a lecture, and then the last 2 hours will be the exam. It'll run for those 2 hours. But you should be done much earlier than that. Anything else? All right, excellent. Thank you. Yes. Yep.
I'm not too sure how to do that.
What do you mean?
I don't have a TA responsible for my grading. I have assignment 1 graded.
Okay.
But I joined the group, the class late.
Okay.
And I don't have assignment 3 graded. I think it should have been graded.
Yeah.
I was asking Brian, but
So what's your name?
it's Ayush. AYUSH.
Please. How do you spell it?
AYUSH.
AYUSH.
Yeah. You need the last name?
Oh, that's your first name?
That's my first name.
All right, last name?
Dhananjay. DHAN. AN again. JAI. Yep.
I don't either. I am trying to line.
Thank you,
Okay.
Professor.
No,
Appreciate it.
Somebody will reach out to you.
Thank you. I appreciate it.
All right, good luck.
What are the deliveries to the project?
And yeah, I was going to start talking about that after the midterm.